Good morning everyone. Today we all are gathered here to conduct our next activity which is named lecturing. It means we all have explained any one topic regarding our syllabus or any other what you want. Then one by one we should start to explain activity. Then firstly I am varsharani and I am going to explain the classification of microcontroller. Basically, microcontroller is broadly classified into based on various fields, such as according to the memory, microcontroller is classified as external memory and the embedded memory microcontroller. Then, according to the bit configuration, microcontroller is broadly classified into 8-bit microcontroller, 16-bit microcontroller, and 32-bit microcontroller. And then, based on the instruction set, microcontroller is broadly explained into the two instruction set, that is CISC and RISC. And based on the architecture, microcontroller is classified into two architecture, that is one is one-to-one and another one is hardware. I will explain you one by one in detail. First, I will explain you the classification of microcontroller based on the memory. Microcontroller is classified based on memory. First is external memory. External memory microcontroller, and another one is the embedded memory microcontroller. Embedded memory microcontroller. In the external memory microcontroller, all the program memory and data memory are not on a single chip. Example of external memory microcontroller is 8031 microcontroller. Another one is the embedded memory microcontroller. It means all the program memory, data memory, timer, counters, interrupts, input, output, source, all are the same on one chip together. For example, 8051 microcontroller. The microcontroller is classified based on architecture, that is one-to-one architecture and hardware architecture. In one-to-one architecture, microcontroller has separate address units for the data memory and the program memory, and separate address bus. And in the hardware microcontroller, in the hardware architecture microcontroller, program and data memory has separate address unit, and buses are also separate. Whereas in the hardware architecture, there is common unit, common memory unit for storage of data and memory. Microcontroller is classified based on the bit configuration, that is 8-bit microcontroller, 32-bit microcontroller, and 16-bit microcontroller. In the 8-bit microcontroller, 8-bit microcontroller is used for various logical and arithmetic operation, such as addition, subtraction, multiplication, and division. Then this example of 8-bit microcontroller is 8051 microcontroller. Then 16-bit microcontroller. This microcontroller
explain special function register. Special function register, there are 21 special function register, and now I am explain only 4 register, that is Timon, Ticon, Escon and Lucon. And first is Timon. First is Timon, and Timon is 8-bit register, and it is used in my 8051 microcontroller, and these 8 bits and these 8 bits are this is Timor format, Timor register format. This is 8-bit register. First is timer 0 and timer 1. And timer 0 consists of gate 6 slash T bar, M1, mode 1 and mode 0. Gate is select 0 and 1. 6 slash T bar select counter and timer mode, and M1 and M0 select is mode. In Timor register there are 4 modes. First is mode 0. Mode 0 is 13-bit timer. Second is mode 1, it is 16-bit timer. Second is mode 2, it is 8-bit auto reload. And last one is mode 3, it is split mode timer. Mode 1 and mode 0 select 4 modes. There is mode 0, mode 1, mode 1, mode 3. Mode 0 is 13-bit timer. Mode 1 is 16-bit timer, and mode 2 is 8-bit auto reload, and mode 3 is split mode timer. And we'll explain second. Second is T-Con.
श्रुतीला बोलते.
Now, second one is T1 register. T1 register is also 8-bit register, and this is used in 8051 microcontroller. And T1 register consists of 8 bits. There are TF1, TR1, TF0, TR0, IT1, IT1, IT0, and IT0. TF1 is overflow timer 1, and TR1 is timer 1, 0, 0 is overflow timer 0, and IT1 is external interrupt, and IT1 is internal interrupt, and IT1 is external interrupt. direct addressing mode. Fourth, register indirect addressing mode. Fourth, index. Fifth, index addressing mode. Five, first we explain immediate addressing mode. Example of immediate addressing mode. Move A 0A fetch. Move R3 semicolon 45 fetch. In these are immediate addressing mode. Semicolon is most important part. Second, register addressing mode. Examples of this register addressing mode is move A R5. In this addressing mode, this instruction will not use move R5 R7, but this instruction will replace this instruction move A R5 move R7 A. Third is direct addressing mode. Examples of this addressing mode is move R2 45H and move R0 05H. Fourth is register indirect addressing mode. Example is move 5H at rate R0 and move at rate R1 8PH. In this addressing mode, at the rate is the most important part. Five addressing mode is index addressing mode. Examples move C A at the rate A plus PC and move C A at the rate A plus PPTR. PC and PPTR is only two contents usually in index addressing mode. PPTR full form is data pointer register. This is special function register. Last one is implied addressing mode. Examples of this addressing mode is RLA and SWAP. Thank you so much.
Okay, everyone. My name is Priyanka Kapoor. Today I am presenting block diagram of operational amplifier. So firstly, see the structure of operational amplifier. So there are two inputs, non-learning and learning, and four stages. Input stage, intermediate stage, zero stage, output stage, and then output. So operational amplifier is a multi-stage amplifier. Input stage is a dual input, balanced output, and differential amplifier. It provides a voltage gain. It provides a voltage gain of the operational amplifier and establishes the input resistance of the operational amplifier. Then second is the intermediate stage. It is another type of differential amplifier, and most of the amplifiers of the in the intermediate stage, dual input unbalanced output is present. In intermediate stage, because in intermediate stages, DC coupling are used. In this intermediate stage, the DC voltage and the output of the DC voltage of the resistance of the intermediate resistance as well as ground potential. And then after that level shifting stage, after intermediate stage there is a level shifting stage. In this level shifting stage, the DC level shift the output voltage of the intermediate stage to ground, downward to 0 volts with respect to ground. And there is output stage. In this stage, there are push-pull amplifier are used in this output stage, and then output. Well-designed output stage it provides input low resistance. So this is the structure and explanation of the block diagram of operational amplifier. Thank you.
Hello everyone, my name is Varsharani. Now today I am explaining you the communication protocol in microcontroller.
for interfacing devices. Another is a serial peripheral interface. It is a synchronous serial communication. It is synchronous serial communication. It is master slave architecture. And it is for interfacing with sensors, LEDs, and displays. What I consider about it is integrated circuit is a synchronous communication. It is multi-customer display architecture. It is commonly used for interfacing with devices like displays. Last one is CAN protocol. It is control area interface. Control area network is called multi-master architecture. It have multi-master architecture. It is serial synchronous serial communication. It is used for command and medical applications. Each protocol has its strength and it is used for specific applications.
I am Vishnu Prakash Patil. I am now going to explain pin diagram of 8051 microcontroller. Here is a pin diagram of 8051 microcontroller. It has 4 ports, port 0, port 1, port 2 and port 3. And here is port 0, port 1, port 2 and port 3. In port 1 pins are pin number 1 to 8. These pins are bidirectionally input-output ports. Pin 9 is a reset pin. It is a reset microcontroller to its initial state. And port 3 start from pin number 10 to 17. It serves as some functions like interrupter, timer, control unit, serial communication, RxD, TxD. And port pin number 18 and 19 is a crystal pin, which is used to interfacing external crystal to get the system clock. Pin number 20 is the ground pin, and then it provides power. And pin number 21 to 28 is a port 2, which has an input-output port. It is the higher order address bus of the signal. Pin number 29 is a PSEN pin, which stands for Program Status Enable, which is used to read signal from external memory. And pin 30 is a ALE, which stands for Address Enable, which is used to demultiplex signal of address and data bus. Pin 31 is a EMB, which stands for external access, which are used to enable or disable the external memory interfacing. And here is transport 0. Port 0 pins start from 32 to 39. It has input ports and it is a lower address data bus are multiplexed using these ports. And pin 40 is a VCC.